For centuries, humans have gazed at the stars, their eyes filled with wonder and curiosity. The night sky, with its twinkling stars and mysterious planets, has always been a source of inspiration and dreams. Ancient civilizations built monuments aligned with celestial bodies, and astronomers mapped the heavens, seeking to understand our place in the universe. We long to explore the cosmos, to venture beyond our world and uncover the secrets of the universe. The dream of space travel has been a driving force for innovation and discovery, pushing the boundaries of what we thought possible. But reaching space was expensive. The cost of building and launching rockets was astronomical, limiting space exploration to a select few missions. Governments and space agencies had to carefully allocate resources, often facing tough decisions about which missions to prioritize. Each rocket was used only once, making space travel an unsustainable endeavor. After a single journey, these rockets would be discarded, their stages falling back to Earth or left drifting in space as debris. This single-use approach was not only costly, but also environmentally unfriendly. Scientists and engineers dreamed of a better way. They envisioned a future where space travel could be more efficient and sustainable. Brainstorming sessions and design sketches filled their days as they sought to revolutionize the way we reach the stars. They imagined a reusable spacecraft, a vehicle that could be launched, return to Earth, and be launched again. This concept promised to drastically reduce the cost of space travel and open up new possibilities for exploration and innovation. This vehicle could travel to space and back many times, making it a game-changer in the field of space exploration. The idea of a reusable spacecraft was not just a dream, it was a vision of a more sustainable and accessible future in space. It would make space travel more affordable and accessible, allowing more missions to be launched and more discoveries to be made. The potential for scientific research, commercial ventures, and even space tourism became more attainable with the promise of reusable spacecraft. The idea of a spaceplane landing like an airplane was born. This innovative design would enable the spacecraft to glide back to Earth, reducing the wear and tear on the vehicle and making it easier to refurbish and relaunch. It would launch like a rocket and glide back to Earth, combining the best aspects of both technologies. This hybrid approach promised to make space travel more efficient and reliable, paving the way for a new era of exploration. This concept captured the imagination of people worldwide. The idea of a reusable spacecraft resonated with the public, sparking excitement and hope for the future of space travel. News headlines and media coverage brought the vision to life, inspiring a new generation of dreamers and innovators. The Space Shuttle was going to be a game changer. It represented the culmination of years of research, development, and dreams. As the shuttle stood poised on the launch pad, it symbolized the dawn of a new era in space exploration. It promised a new era of space exploration, one where the stars were within reach and the possibilities were endless. The dream of reusable spacecraft was no longer just a vision. It was becoming a reality, ushering in a future where space travel was more sustainable, affordable, and accessible to all. The 1960s saw the United States determined to reach the moon. This era, marked by the intense space race, was a time of rapid technological advancements and fierce competition with the Soviet Union. The Apollo missions were a testament to human ingenuity and ambition, culminating in the historic moment when Neil Armstrong set foot on the lunar surface in 1969. But even as Apollo took flight, plans for a reusable spacecraft were taking shape. Visionaries at NASA were already looking beyond the moon, dreaming of a vehicle that could make space travel more routine and cost-effective. These early sketches and designs laid the groundwork for what would become one of NASA's most iconic programs. NASA engineers began working on various designs. They faced many challenges. The concept of a reusable spacecraft was revolutionary, requiring innovative solutions to problems that had never been tackled before. Engineers had to consider everything from the spacecraft's aerodynamics to its thermal protection systems. The shuttle had to withstand extreme heat upon re-entry. This was one of the most critical challenges. Engineers conducted numerous tests, simulating the intense heat and pressure the shuttle would face as it re-entered Earth's atmosphere. They experimented with various materials and designs to ensure the shuttle's safety and durability. It also needed a flexible design for different mission types. The shuttle had to be versatile enough to carry astronauts, satellites, and scientific equipment, this required a design that could be easily adapted for a variety of missions, from deploying satellites to servicing the International Space Station. After years of research and testing, the final design emerged. This design was the result of countless hours of brainstorming, prototyping, and rigorous testing. It represented the culmination of years of hard work and dedication by NASA's engineers and scientists. The Space Shuttle consisted of three main parts: the orbiter, the external tank, and two solid rocket boosters. Each component played a crucial role in the shuttle's operation. The orbiter housed the crew and payload, the external tank provided the necessary fuel, and the solid rocket boosters gave the shuttle the thrust needed to reach space. The orbiter, shaped like an airplane, housed the crew and payload. It was designed to be both a spacecraft and a glider, capable of re-entering the Earth's atmosphere and landing on a runway like a conventional aircraft. This innovative design made the shuttle unique among spacecraft. This remarkable vehicle was designed to be partially reusable, making space travel more sustainable. After each mission, the orbiter could be refurbished and prepared for its next flight, significantly reducing the cost of space exploration. This reusability was a game-changer, paving the way for more frequent and affordable space missions. The dream of a reusable spacecraft was becoming a reality. The Space Shuttle program marked a new era in space exploration, demonstrating that with determination and innovation, humanity could turn its dreams into designs and make the impossible possible. Excitement reached fever pitch as the first space shuttle, Columbia, was prepared for launch. On April 12, 1981, the world held its breath. Columbia roared into the sky, marking the dawn of a new age in space exploration. The mission was a success. Astronauts John Young and Robert Crippen returned to Earth 2 days later. Columbia's successful flight proved that reusable spacecraft were possible. This achievement paved the way for a new era of space exploration. The shuttle could carry astronauts, satellites, and even large structures like the Hubble Space Telescope. The future of space travel had arrived. Following Columbia's success, NASA built a fleet of space shuttles. Challenger, Discovery, Atlantis, and Endeavour joined the ranks. Each shuttle embarked on various missions, pushing the boundaries of space exploration. They deployed satellites, conducted scientific experiments, and even helped build the International Space Station. The shuttles became a symbol of American ingenuity and the pursuit of knowledge. They inspired generations with the wonder of space travel. These incredible machines were much more than just vehicles. They were flying laboratories and symbols of human ambition. The Space Shuttle program became a source of national pride and international collaboration. The space shuttles played a vital role in advancing our understanding of space. These incredible vehicles were not just modes of transportation, they were floating laboratories, observatories, and repair stations all rolled into one. Each mission carried with it the promise of new knowledge and the potential to push the boundaries of human understanding. They carried astronauts to repair and upgrade the Hubble Space Telescope. This iconic instrument has provided us with some of the most detailed images of the universe ever captured. The shuttle missions ensured that Hubble remained at the cutting edge of astronomical research, allowing it to peer deeper into space and further back in time than ever before. This led to groundbreaking discoveries about the universe. From identifying distant galaxies to uncovering the mysteries of black holes, the Hubble Space Telescope has revolutionized our understanding of the cosmos. Each image and data set it sent back to Earth opened new windows into the vast expanse of space. Shuttles also transported modules and equipment for the International Space Station. This collaborative effort among nations has created a unique platform for scientific research. The shuttle missions were crucial in assembling the ISS piece by piece, module by module, transforming it into a fully functional space laboratory. This orbiting laboratory has allowed for continuous research in microgravity. Scientists aboard the ISS conduct experiments that are impossible to perform on Earth, taking advantage of the unique conditions of space to study everything from fluid dynamics to biological processes. From studying the effects of space on the human body to observing distant galaxies, The research conducted on the ISS has far-reaching implications. It helps us understand how long-duration spaceflight affects astronauts, which is crucial for future missions to Mars and beyond. Additionally, the ISS serves as a vantage point for observing celestial phenomena. The shuttles made countless scientific breakthroughs possible. Each mission was meticulously planned to maximize scientific output, whether it was deploying satellites, conducting experiments, or repairing existing space infrastructure. The versatility of the shuttle program was one of its greatest strengths. They helped us unravel the mysteries of the cosmos and our place within it. The data and insights gained from shuttle missions have been instrumental in shaping our current understanding of space. These missions have inspired generations of scientists, engineers, and dreamers to look up and wonder about the universe. The data gathered from shuttle missions continues to fuel scientific discoveries today. Researchers around the world analyze this treasure trove of information, leading to new theories, experiments, and innovations. The legacy of the Space Shuttle program lives on, driving humanity's quest to explore the final frontier. The Space Shuttle program wasn't without its challenges and risks. In 1986, the world watched in horror as the Challenger disaster unfolded. 73 seconds after liftoff, a booster failure caused the shuttle to break apart, claiming the lives of all 7 astronauts on board. Then in 2003, tragedy struck again. Space Shuttle Columbia disintegrated during re-entry. A piece of foam insulation had broken off during launch, damaging the heat shield. All 7 astronauts perished. These tragedies were stark reminders of the inherent dangers of space exploration. They led to significant improvements in shuttle safety and operational procedures. Despite the tragedies, the Space Shuttle program continued. The shuttles flew again, demonstrating resilience and a commitment to space exploration. They completed construction of the International Space Station and conducted numerous scientific missions. After 30 years of service, the program ended in 2011. The 5 shuttles, now silent, are museum artifacts. They stand as a testament to human ingenuity and the relentless pursuit of knowledge. The shuttles played a pivotal role in expanding our understanding of space and inspiring future generations. Their impact on space exploration is immeasurable. The Space Shuttle program left an indelible mark on history. It showed us that reusable spacecraft were possible. It pushed the boundaries of technology and expanded our understanding of the universe, but most importantly, it inspired generations to dream of reaching for the stars. The spirit of exploration embodied by the Space Shuttle program lives on. It continues to motivate scientists, engineers, and dreamers worldwide to push the boundaries of what's possible. The quest to explore the cosmos continues, fueled by the legacy of the Space Shuttle. The story of the Space Shuttle is just one chapter in the ongoing saga of human space exploration. From the first rockets to the International Space Station, our journey into space is filled with incredible achievements and inspiring stories. Subscribe now for more daily history and delve deeper into the fascinating world of space exploration.